Hi students, this next unit we are going to be studying geometric formulas. So we're going to be looking at area formulas of a lot of polygons that we've already studied. Also circles and composite figures will be a little bit new to us. And then we're also going to look at volume formulas. So volume is dealing with three-dimensional objects. So in today's video, we're just going to focus on the area formulas for parallelograms, triangles, and trapezoids. And then next class, we will talk about rhombuses, kites, circles, and composite figures. All right, so let's start with parallelograms. So we've already studied parallelograms. We know all the characteristics, all the features. So we're going to just focus on area. And area is all of the space inside of a figure. So for example, in this polygon, if we wanted to know the area, we want to know, what's all this space inside. So if we were to color in this entire parallelogram, that would be representing the area. And area is measured in square units. So for example, we could have centimeters squared, inches squared, feet squared. You kind of get the idea, okay? So the formula for a parallelogram is base times height, where the base is really any one of the four sides, okay? Typically we think kind of just that, bottom side. And then height, exactly what it sounds like, how tall is your parallelogram? And we talked a little bit about this with triangles earlier this year, but to measure the true height of a figure, it is the perpendicular distance from the top base down to the bottom base. Okay, so in the drawing there on your notes, you can see the height there represented. It doesn't have to necessarily be there. We could look over here and find a perpendicular distance. We could actually measure it outside of the parallelogram if we extend the base there. Okay, so all of these heights would be the same distance. So let's take a look at an example. So in this example one, we want to find the area of this parallelogram. So area again is base times height, where in this case we've got a base of 28 feet times a height of 10 feet. So if we multiply those together, 28 times 10 is 280, and our unit is feet squared. And that's it. All right, next one, find the area of the parallelogram, but first we have to find the height. So some of this information is missing here. So our parallelogram, just highlight that. That's good. Okay, so this is the parallelogram we're looking at. We have the base here is 10 meters, and we need to know the height. All right, so notice what we can do is create a right triangle. So if we extend that base just by 6 meters down here, we've got this side of the parallelogram is 10 meters, and we need to find the height. So we can make a little right triangle there. And if I pull that out separately, so we've got 6, 10, we're looking for the height. When we have 2 out of 3 sides and we need to find the third, what can we use? Pythagorean theorem. So 6 and H are my A and my B. 10 is my C. So we can set up 6 squared plus H squared equals 10 squared, which is 36 plus H equals 100. And then if we subtract 36 from both sides, H equals, oops, I lost my exponent, H squared. H squared equals 64. Take the square root of both sides. h equals 8. So if we go back up to our original image here, we can put in an 8 here for the height. We have 10 as our base. So the area of the parallelogram, base times height, would be 10 times 8, which is 80, and our unit is meters squared. Okay. All right. Why don't you pause this and try this next one? Okay, so if we start with our formula, area equals base times height. Now this time we've got our base is 7 centimeters, but we're looking for the height, and we're given area is 28. So we're using the formula, but just now this time we're solving for h instead of a. So we plug in 28 for a, plug in 7 for b, and then solve for h, which is one quick little step here. All we have to do is divide both sides by 7, so we get 4 centimeters for the height. All right, moving on to triangles and trapezoids. They have very similar area formulas, which is why they're put together here. So for a triangle, the area is 1/2 base times height, where the base and the height are perpendicular, just like in parallelograms. So the base really can be any one of the 3 sides of a triangle. And then again, the height is measuring the height, like the total or the length from the very bottom of the base to the very top, right? The total height of the triangle, but it's at a perpendicular distance there. And just to kind of give you an idea, I'm going to sketch a few other triangles. So just some other scenarios, you could have a right triangle, which in that case, the height is one of the legs of the triangle, and then the base is the other leg. Okay. Or you could have, if you have an obtuse triangle, then if you want this bottom side here to be the base, then you have to, just like in that one parallelogram we just saw, you could extend the base to make a perpendicular measurement up to the top, and then that would be your height. Okay. Okay. Moving on to trapezoid. So the formula, since we've got 2 bases in a trapezoid, you add those bases together, multiply by the height, and then times 1/2. So kind of similar to a triangle. Or another way to think of that is you could just do base 1 plus base 2 times height divided by 2. So really it's whatever you prefer. You can do base 1 plus base 2 times height times 1/2, okay? Or 1/2 times base 1 plus base 2 times height. Or you can add the bases together, multiply by the height, and then divide by 2. Which that's the one I normally like to do. So let's look at this triangle first, okay? So we've got this 48, that's our base. Perpendicular distance to the top of the triangle, 23, that's our height. So it's just plugging into the formula and solving. So area equals 1/2 times 48 times 23. Punch that into your calculator, you get 552. We are in inches squared. All right. Take a look at this triangle. So here again, kind of an idea of showing you how we have an obtuse angle here. So it's an obtuse triangle. So if we extend the base, then we can go up to the top to find the height. Now, this 34 here really is not necessary for this example because the triangle that we're looking for here, the base is only the 118. And then the height is 52. Okay. So area equals 1/2 base times height. 1/2 times 118 times 52. Put that into our calculator and we get 3,068, and this is millimeters squared. Okay. All right, now here's our trapezoid example. So really the only difference now is we've got two bases. So we're going to add our bases together first. So base 1 plus base 2 times the height, and then divide by 2. Or you could, if you want to think of it more like the triangle, 1/2 base times height, you could go 1/2. But this time your base is the sum of the two bases and then times your height. Okay, so first thing is let's identify all of our pieces parts here. So we've got our two bases, 52 and 78. And then the height is, again, that perpendicular distance between the two. So that's 22 meters. It could be anywhere inside the trapezoid, okay, as long as it's a perpendicular. Whoops, the highlighter never seems to work well. Let me get back to my pen. So as long as the height is perpendicular to both bases, then you know it's the height. So these would all have a measurement of 22 meters. All right, so let's set up our equation. So I'm going to go with the first option there. I'm going to take my two bases, 52 and 78, add them together, multiply by the height, 22, and then divide by 2. So if I add the two bases, that's 130 times 22 divided by 2. If I multiply my numerator, that's 2,860 divided by 2. And then simplify that, you get 1,430 meters squared. Okay. Just the other way to write it, I'll just show you here. So if you want to do 1/2 times base times height, but this time we would add our two bases and then times our height. So we'd still add the bases together first and get that 130. And then from here, you could just do this all in your calculator, just like the triangle. 1/2 times 130 times 22, and then you're going to get the same answer, 1,430 meters squared. And just a little kind of helpful hint, in your calculator, when you're dealing with the 1/2 in this formula and the 1/2 in the triangle formula, if you're using your calculator, feel free to put in 0.5. It might even just be easier and avoid any errors with using fractions or dividing in your calculator. All right, and that's it for this video. So in class, we will talk about rhombuses and kites and circles and composite figures. So for right now, the idea is just to start becoming familiar with these formulas. And I will also add that you're going to get a formula sheet whenever you are quizzed on this, okay? So don't feel like you have to memorize these formulas. You just have to know how to apply it like we did in all of these examples. All right, see you in class.